Well, welcome everyone to this Open Group webinar, which today is being brought to us by our friends at Avolution. Before I hand over to our speakers, Tim and Andrew, I'd just like to go over a few housekeeping issues to keep today's event moving forward smoothly. Firstly, with regards to questions, and of course we would encourage you to ask questions of Tim and Andrew today. If you'd like to do so, the best way to do that is to write your question in the QA text facility. If you do write a question in there, can I ask you to address it to all participants? That way everyone gets to see all the questions that have been submitted, and our intention is to try and answer as many questions as we can at the end of today's presentation. If you'd like to simply share an opinion or a comment with a fellow attendee, then the best way to do that is in the chat facility. So questions in the text QA and comments in the chat, please. Now today's event is being fully recorded, so if for any reason you have to leave early, or if you experience any local technical difficulties, and I know sometimes audio can be a little problematical in various countries, then everyone who is registered for today's event will get an email with a link to the event recording tomorrow. So Tim and Andrew, if you're ready to go, can I ask you to start today's presentation?
Yeah, thank you, Simon. Andrew, yeah, do you want to jump to the next slide, I guess? There's no need to. Okay, a quick introduction. You obviously know that you're all here. My name's Tim O'Neill. The topic today is all going to be about technical debt and how that relates to architecture and sort of looking a little bit at how the Open Group positions itself with regard to that and how we do. But yes, us as a company, Avolution, you've all heard of us. We've been around for 20 years now. I'm sure most of you saw, I think it was last week, the latest Magic Quadrant came out where we are the leader there. So yeah, we obviously have great reputation in the market, and we're all around the world, and I'm sure there'll be lots of clients on this call and hopefully lots of people who will find out some more about us. So myself personally, I've been with the company since it started. So I was one of the original founders. I now get involved in all the kind of major projects we do, the major clients that we work with, and sort of float between a few different areas in the business. Today I've got one of my colleagues, Andrew. I guess I'll leave it to you, Andrew, to introduce yourself.
Yep. Hi, everyone. I'm Andrew Luthwig. I work as a consultant for Avolution, and as that kind of short bio states there, I've worked with various customers delivering some of these use cases or drivers, if you like, around things like digital transformation, application rationalization, and of course things like technical debt here as well.
Probably going to have a word with our marketing department. I'm clearly the one without the hair, with hair by the looks of it. So there you go. Okay, I guess next slide. Okay, so yeah, a little run through. I mean, I'm sort of just going to set the scene a little bit, and Andrew's going to do the bulk of this, so don't worry. So really the agenda today, we will try and sort of position, kind of make a bit of a position statement about, well, A, where the Open Group sits on this topic through its standards, TOGAF and ARCHIP primarily, where we sit on this standard, and fundamentally how we think technical debt is certainly something you can model. And what I mean by model is actually put some numbers to it, and then you can use algorithms and things like that to calculate it. So it is a good deterministic measure that you can use to shape the way that you're designing the roadmaps and the future of an organization. So there's lots of good technical terms here that we'll sort of go through. There's obviously a lot of history in the concepts from financial modeling, so we'll try and apply some of that, and Andrew will take you through things like debt ratios and stuff like that. But of course, numbers and death by spreadsheet is not the way to go to make decisions. So we'll try to show you some visualizations that we found pretty useful as a way of communicating this. And fundamentally, what is technical debt useful for? It's a good driver for setting your roadmaps. So ultimately, it's about how do you make your business better, right? And indeed, try to reduce something like technical debt. Okay, so yeah, next slide. So I'll just sort of position it in things like the Open Group standards, like TOGAF and ARCHIMATE. So I guess the first thing to point out here, and I don't know if any of you guys have done it, we've certainly done it, but if you type the word technical debt in, you don't get a hit in the standards. Okay, so it's certainly something that's not explicitly discussed. There is, of course, in TOGAF, there is a concept where there's sort of some other words that relate to the field of technical debt. So ultimately things like waivers and exceptions in a governance process is the way in which you try to embody technical debt. So certainly there is some mention of those concepts. Indeed, in the ADM, in TOGAF, in Phase H, you've got, of course, architecture change management, that's Phase H. There is the whole concept of change requests Okay, and change requests do have one of the inputs being the business exceptions you're trying to cope with. Okay, so an exception is of course something like you're allowed to use a certain version of SQL Server even though it's not necessarily the standard version that the company would normally recommend. Okay, so that's a classic waiver or exception. Now of course by doing that you are fundamentally starting to incur some technical debt or some enterprise debt. So indeed, they do have principles then. So here we've listed principle number 20. There's about 40 principles, I think, from memory in the reference models in TOGAF. So this one about controlling technical diversity is clearly a principle that is trying to minimize that situation where you'll end up with non-standard technologies, which ultimately are starting to incur some technical debt for you. So it's not, it should never be megalomaniacal. You shouldn't always, have any color as long as it's black, Model T Ford methodology. But fundamentally, try to minimize that technical diversity is clearly a driver from something like TOGAF, which is related to, of course, technical debt. Archimate is a fair bit more limited. There is no methodology really at Archimate, so nonetheless you wouldn't expect there to be too much about technical debt. There isn't even any real vehicles in the meta model within within Archimate to capture these sorts of things. So of course what we're going to talk through today is some techniques that we think you can use to extend something like Archimate with these sort of things, and we've of course done that already in our libraries, but nonetheless it's the kind of background theory. And ultimately, really, what you need to sort of see this technical debt side of things as, when you're doing road mapping, fundamentally, you're trying to change the business. Okay, and that's what Phase H is all about, architecture change management. So you're really trying to just stop people from doing bad changes. Right, that's the idea. Technical debt is something that's trying to say, look, if you're going to decide on some future project or transformation, if one of your KPIs is technical debt, then either you're going to be recognizing that by doing something is going to start to incur some technical debt, or of course, conversely, doing something, a change, might hopefully remediate that and start to reduce the technical debt and make you more compliant. So it's all about change management and fundamentally, yes, not making bad changes. Okay, so with that, I will pass to Andrew and let him go through the bulk of how we sort of position this and give you some sort of technical takeaways that you can use. And I will sort of man the Q&A session. So please, put your questions in the Q&A session. Behind the scenes, I'll answer any that I can on the fly. Some of them, of course, will be good for discussion, and I'll flag those and we'll talk about them at the end. So don't be shy. Put as many questions as you can in there. I'll take them live. And yeah, obviously, Andrew, take it away.
Yeah, perfect. Thanks for that, Tim. So the first thing, I guess, that I do want to get back to, I guess, is this term technical debt. So it's probably worth going through very quickly, I guess, where this originated from. So some of you might have heard this term before. Others on the call perhaps haven't. Initially, it was actually a term that was coined by Ward Cunningham in '92, and it is mainly focusing on software design or software architecture. Now, there have been deviations from some of the definitions over time, but effectively you can think of technical debt as essentially some kind of incurred cost when there is some kind of poor design or poor implementation decisions that have been taken. They typically stem from moving fast. In the short term, you're trying to release some new features in any products or services that you're delivering without perhaps taking into consideration that longer term view where things perhaps could be more efficient and where the code could be more maintainable and the code base itself has a bit more sanity to that. I think over the years that definition itself has, I guess, wavered. I don't think anyone these days actively writes bad code in any way, but certainly when code is written quickly, they might only be writing that for the initial requirements at hand to get those features out of the door. So you will see that in today's world, engineering teams are perhaps maybe pressured a bit more to get those features done quickly, rather than maybe think of how those could be more beneficial in the long term. And you'll see a quick stat here, of course, saying that an average of 25% of the overall development time is actually dedicated to managing technical debt. And that's, of course, from a developer's perspective then, of having to review some of that code base. Another way you can quickly think of debt is thinking of it as normal debt, so any financial debt that you might incur. So there are multiple levels of debt, of course. There's that concept of course, having to pay that debt back at some point. So you've heard Tim talk about the idea of capturing things like waivers or exceptions. You will ultimately have to pay that back. Now that also comes with some kind of time frame. So you're going to be accruing interest on that technical debt throughout the life of an application or a feature or a service that you're implementing effectively. Now, a couple of quick examples of what technical debt might look like these days. Typically, it might be a lack of documentation, maybe failure to write test programs, attending to any of the comments that are in there, or where the code generally is maybe just too confusing and then can't be easily modified. The technical debt in general, I guess, doesn't really surface in normal day-to-day use. Your software is usually designed to handle almost 95% of the possible scenarios that we face. So anywhere you put that piece of software, we tend to think of those scenarios as almost like use cases. And there are, of course, the 5% that aren't covered, so the edge cases, if you like. These are typically things that are going to be quite rare, maybe things that shouldn't actually happen, or what we might typically think of as caused by user error. Now, of course, the more complex these systems get, you can never really foresee every possible scenario, so predicting every edge case is typically very difficult to do, but it is about trying to understand where you can actually start predicting that. Technical debt in itself, I guess, falls into many categories, and we're, I guess, generalizing in this aspect, but you can have almost what we call reasonable debt in here, which is things that are, I guess, unavoidable. There are time constraints or resource limitations where that development work is taking place, so that's debt that I guess is expected. But then, of course, there is negligent debt. Maybe there is a lack of knowledge in certain areas, maybe there's a lack of foresight or planning on that code base, or of course is the outright ignoring any consequences of any short-term fixes that you're actually making to that code. If we think about this in almost like a framework perspective, if you like, I know that every EA enjoys some kind of classification framework. This one is actually showing you the things in orange here are effectively the features that get shown through. So these things are visible and they do provide some kind of positive value. Okay, so maybe these are improvements to some kind of quality attributes as well. You'll see the things in the bottom left. There, I guess, references a bug. But these are things that when the software is already released, it does at times have defects. So there are, of course, times when that code needs to be changed. And that's, of course, fixes that we then apply to that code base. Of course, there are some trade-offs there that need to happen, of course, when you fix those bugs. And they might be, in fact, dropping future features. Now, we've actually categorized those, or certainly in this framework that we're using here, and classified those as what we might call visible items, things that people tend to see, whether it's us internally as teams, or, of course, customers that are using our services. Then there are the invisible things. We have kind of architecture changes to code as well, and these are a bit more difficult to break down, if you like, but they tend to add more value in the long term, whereas features tend to be seen as more of a short-term thing. And they often are key quality attributes that we are changing around that code. This is relatively difficult to define at times in terms of a code base, but they are the underlying structure of that and how those features are actually going to be supported. And then, of course, the gray stuff in that bottom right-hand corner in terms of tech debt. These are the things that do have negative value on an organization and typically are invisible. Essentially, when you're making those architectural decisions, they're probably optimal at the time, but over time that does need to change, and that is when you start accruing technical debt. So it's mostly things that is known by the development team, but it's rarely expressed visibly, if you like, at that level of key decision makers. And you'll see a quick stat on that later on as well, in terms of how that's actually managed. Now, technical debt, again, being a relatively software term here, there are a few, I guess, real-world examples of this. And you can almost think of some of these things in terms of outside of an organization or a software world. So there's actually a real-world example from 2014, slightly unrelated to businesses as such, but there were a couple of earthquakes that happened in 2014 in August. Those earthquakes actually hit California and China in the same month. What the outcome of that was a number of damaged homes from those earthquakes. In California, in fact, there was a total of 4 homes that were damaged. Same month, same magnitude of earthquake in China, just under 26,000 homes were damaged. And there's a single difference here that we can relate to, which is quality. Homes in China in that particular region, that particular time, were built quickly, and there were kind of cursory inspections that were happening. In the United States, it was quite the opposite. Those houses which were in the earthquake-prone areas, they were built to very prudent, exacting standards. Now, you can resemble this back to software. We typically build software, or sometimes we build software, that is quick to get those features out. But just like those houses can't withstand any earthquakes, the poor quality code might look fine from the outside, but over time you will find that there's a hidden cost in that code that then does have to be paid back at a later date. You'll actually see this in some very big software companies these days. So if you take a quick example of Twitter, back when that was first formed, its initial platform was actually built on Ruby on Rails. So it was relatively new, I guess, and they were trying to use some of the newer technology at the time, and certainly was fit for purpose when that platform was released. That quick solution, though, did come at a relatively steep price. It was very difficult for Twitter to add features or improve its search performance. Over time, what happens generally with technical debt, and as what happened with Twitter, they paid down that debt. They switched over to a Java server, and ultimately that did lead to almost a 3-fold decrease in search latency throughout that product. This particular example is a great case for technical debt. Even more so in the last, I was going to say years, but probably in the last few months, you would have seen some of the even recent security hacks into some of the biggest Fortune 500 companies. And effectively, that is partly down to some of the technical debt that is involved within the code that's been built there. And it does have a role to play in most of those scenarios. So what you will actually find, as this slide states, that technical debt at its core is essentially risk management. Now, as with everything, of course, there's only one way of knowing how to make changes within any organization or any platform, and that's being able to measure technical debt. So again, from a software perspective, true technical debt, I guess, because it was born out of software, does require some key technical metrics. If we start thinking about code, we can think of the depth of inheritance within that code, how many comments are there, how many lines of code, how easy is that to change. And these are some of the technical models that we can use and technical metrics that we can actually define what we call a technical debt ratio. Okay, so you can kind of see this TDR value, if you like, as more of a measure of quality of code. Now, this is a factor of the remediation costs and the development costs there. Now, effectively, what you're seeing for the development costs and remediation costs could be financial metrics. We've seen that happen before, but they can also be time metrics. And using that, we can try and execute some kind of ratio where we can decide, well, do we accept anything maybe above 5% as a technical debt ratio? And anything below that value we might just actually live with for the time being. One of the best ways, of course, of moving forward in this area is to try and convert these into almost more business-centric terms and try to bring technical debt up to a level that these days you might have heard as more enterprise debt or architecture debt. So enterprise debt is actually one way of just trying to communicate this up to those decision makers or key stakeholders. So yes, we're probably deviating away from the true nature of the definition of tech debt, but we really do need to try and understand how this affects the wider organization and, of course, what the potential risks and opportunities are that we're going to be facing. One way of doing that is actually classifying that debt, or at least rolling this up. So you'll see here we've talked about cost of compliance, but there are also things like business risks and technical risks that are actually associated with the accumulation of that tech debt within the organization. Now, this can also lead to things like regulatory compliance. When there are new standards being introduced, whether they are tech standards or business standards, we do need to understand how they're going to be impacted, or how the systems we're supporting are going to impact those compliance metrics as well. The impact of that debt is also something to consider. That impact actually filters down and ripples across the infrastructure, the technology landscapes, the applications we use, the data that we hold in those systems, and any services that we actually deliver to our customers. And again, coming back to those questions on the right-hand side and what we try to use as a definition, this is where the waivers and exceptions can be used. They're architectural constructs. They're ways of managing, I guess, accruing technical debt. But those waivers carry those remediation costs and development costs, and then maybe even cost of compliance or non-compliance. Another key aspect of that, of course, then is a time concept. We do need to understand, when are we actually going to settle this debt, or when are we going to start paying this off? And it comes back, I guess, to one of Tim's earlier examples, if you like. So even if we do have some kind of waiver that says we might be tolerating some old SQL Server system, the remediation costs of that could be significantly higher than just dealing with that over the next 3 or 4 years. So we could live with it for the time being at a cheaper cost than it would be to fix. But with that in mind, there will be a time that comes that we do have to pay off that debt in full. So it is worth remembering how you might get those values out of any systems that you use. Now, that's a lot of metrics, a lot of KPIs, and a lot of data that sounds like is necessary. But there are a couple of ways that tools can help, and of course, frameworks and structures can help. And one of those is actually using various algorithms that are out in the world there today to actually start generating some of this data for you. Now, the benefit of some of the algorithms that are out there is that they do traverse up and down architectures and across. So you can effectively start calculating the necessary properties or KPIs, attributes that are relevant to tech debt. So whether these are financial properties, time, technical details, but effectively allowing you to move what you'll eventually see in these slides as some kind of trade-off analysis. Now, the algorithms themselves, and there are various ways, and you'll see various approaches to this, but the idea is to actually make these algorithms very easy to use and very easy to build, because technical debt, as well as it's being some kind of code-based attribute, it does, as I mentioned, ripple up that architecture. So as much as we might be using old technologies, the applications that are maybe using those technologies are probably supporting some of the processes that are internal. And they indeed might be supporting some of the capabilities that we have further up that line. So using those algorithms, we can actually start calculating some of those metrics, but also rippling that up the architecture and across to make sure that other areas of your organization do actually see the data and aware of how it's affecting their area. Now, it does come, of course, to this point of who actually does care about this. One of the aspects here is actually trying to just raise awareness of this topic. And as I mentioned, of course, there's further developments that are being made across the Open Group, of course, across TOGAF and Archimate around tech debt or enterprise debt in general. But one of the key metrics, and you'll want to see key stats you'll see here, is the visibility of that. And we do talk about technical debt being relatively invisible, but the first task, as with any enterprise architecture mission, if you like, is actually trying to communicate that and making sure there's an understanding. That delivery team on the front line are clearly seeing the effects of tech debt. Perhaps senior management aren't. Perhaps they are just trying to roll out new features from requests, whereas that delivery team and, of course, the product owners do perhaps see the brunt of that and are aware of all the things that need to be changed. There are typically two parts to this, though. We talk about raising awareness, but it is also about motivating the action. How can we actually start convincing people that technical debt is something we need to take seriously, and it's something that actually needs to be actioned immediately? Well, the first thing, I guess, is to think about this in more like real terms. So if you're anything like me, I come into the office in the morning, I open up my computer, and as soon as I start wanting to work on something new, what I usually find is I've got half a dozen windows open, a whole bunch of documents from yesterday that I've been working on, and it's things that are just typically slowing me down. It's the same, in any office environment. You go into a kitchen office environment, you start making lunch for yourself, the kitchen's clogged up, there's old dishes left over, and effectively what you're trying to think of, if this environment was clean, people are less likely to leave, for example, a dirty cup on the counter. If there are dirty cups everywhere, people are much more likely to add their own dirty cup to that environment. And it's exactly the same thing for software and exactly the same thing for how you develop your architectures. The longer you leave things there that are incorrect, that are maybe rotting away, that's when inspiration and productivity goes downhill, and that's when you see this domino effect throughout the organization. So it is partly about taking ownership of what's happening. Just because one thing's wrong doesn't mean we can keep adding to it. It is about trying to find that remediation to the problem. So tech debt, personified in that way, effectively allows us to communicate this in quantitative terms. So then we start thinking of cost, usually monetary. That tends to get people's attention. And then, of course, the impact that tech debt has across the wider organization. Now, here's a quick, research project that was done a few years ago now around the attention span that a typical human has, And we started off relatively high in the years 2000 with 12 seconds as an attention span. And that has, as you can see, decreased quite quickly, actually, over the past 15 years in terms of getting down to 8 seconds. But you're pleased to know it is actually less than the attention span of a goldfish. So one of the key things here is actually just to remember that the world we live in really isn't a time of luxury. We really need to act on the things that we know. And it's not just acting quickly on this content, but it is making sure that you're effectively making things much more efficient for people to see change. Okay. Now, I think I probably spent more than 8 seconds on this slide, so I probably should heed that study and probably move on to the views that are actually going to make this helpful to us to understand. And one of the first ones of those is to make sure that we start communicating and motivating action through the use of the data that we have. We need to focus on some key metrics in that data. A key way of doing that, of course, is to utilize something that is data-driven. So when we start quantifying things like enterprise debt or technical debt, we can start attributing that to different teams or lines of business or different stakeholders so that they are aware of what's happening. The data that is available, and you'll see this across any organization, a key aspect of that is making sure that that's available for users to consume. We don't want to hide these things away. Yes, exposing that tech debt perhaps could be slightly embarrassing to the engineering team, or maybe isn't something you want to show senior stakeholders, but the longer you ignore it, of course, the worse it's going to get. So it's about making that data available. It's about making people consume and update their own data, whether it's in a collaborative environment, and then it's tracking those changes over time. There's a key thing that does help in these situations, and this is from experience of us working with many customers, and that's almost gamifying that data. You've probably heard that term in a few different scenarios, but you're trying to drive change. And one of the key ways of doing that is trying to make this slightly competitive, if you like. So people will want to contribute to making change if they can see that their results and their insights, into that data are helping other people. Of course, that then snowballs nicely into sharing that data. More people are involved, there's more eyes on the problem, and therefore, hopefully, there are more solutions that come to the forefront. And it's about making sure that that data is relatively smart. We don't want to start trying to break down the barriers so much that people are going to be reluctant to contribute information. We want to make it as easy as possible and bringing that attention again to some of the key areas within that data and within, some of the visualizations that you're producing. So coming to the focus, one key visual you'll find is about making sure that this data is available at a glance. So the idea of focusing these metrics, it means that you're making sure that the stakeholders have quick and easy access to certain data points. So it could be things like the cost of developing new programs and how to tackle technical debt. It could be the changes of the technical debt ratio of different projects or programs that you have running. It could, of course, be things like the availability of the systems that you have. You're introducing new projects and programs. You're ideally reducing that technical debt ratio. But how is that actually affecting other areas? By making this available, what you're trying to do is make it queryable. These KPIs in their own right are certainly useful, but where this tends to lead into more engagement is by embedding these into dashboards. So dashboards are, if you like, a fancy word of just a collection of views, and what you're trying to do is build a dashboard for different stakeholders. Each stakeholder has their own responsibility. They'll have their own problems that they have to deal with in the organization. So it is about tailoring the vast amount of data that are out there and trying to pull that up from maybe a software perspective and showing people, how is that tech debt impacting other areas? How do we attribute that to the different locations or the regions that are using those applications or technologies? And how over time is that going to lead to things like business risks? We talk all well and good about the software and the technical details, but from a business perspective, some of these things do reduce time to market. They do have a negative impact, perhaps, on the company's overview and the insights into that company. So it is about making that data available, and it certainly is about embedding that in an environment that people feel that they can prioritize these issues and these problems, and making sure that these risks are addressed early on, rather than letting them fester within any organization. The key thing from this data, of course, is once you have that information, once you've modeled that information, and once you've managed to capture those metrics, you do want to start trying to understand, well, where do we go from here? There are some key fundamentals to this aspect, and one of those, of course, is using something like a roadmap. The first aspect of this is to understand where you currently are today. It's pretty impossible to actually shoot a vision when you can't quite understand what situation you're currently in. But as soon as we know that, then we can start planning where we want to be. Now, it's all well and good saying that this is where we are and this is what we want to be, or a multi-billion-dollar company. That's easy to say, but we do need to start having some rationale around that. Why do we want to achieve that state? Is it because we're trying to work on something like technical debt and reduce that throughout the organization? And as soon as we have those requirements or those statements, then of course we can work through any possible iterations of the transitions in between. Okay, so we talk about things like the transitions, where we are now, where we want to be. These are all fundamental aspects of any architecture and things you'll actually see throughout TOGAF and Archimate as well. These transition architectures that we're working on are effectively trying to help us get to where we want to be. Now, road mapping a technical debt view, if you like, can fall into different categories. So we've talked about how we might classify this data. But one of those is actually using things like projects and programs. You'll know this from experience from using some of the open group standards. Things like projects and work packages, they're effectively the vehicles of change throughout any organization or throughout any architecture. And they are there to deliver some kind of specific outcome. In this case, reducing technical debt. So we can start understanding how that debt accrues across projects and programs and tracing that throughout the entire architecture. The key thing here, of course, is again making this visible because there are multiple projects running. Some projects still use some of those old technologies, some projects are decommissioning them. You need to make sure that there's a traceability. You need to understand how one thing is affecting another thing throughout the organization. You'll see also here, we mentioned this no-code-based approach before because roadmaps in general, I guess a traditional view of taking weeks to build. The idea is that you can start using the algorithms that exist already to help you build these. Whether it is things like, well, what changes should we be making now and what changes should we be making in 6 or 12 months' time? Resource allocation is another key thing. You don't have the time and resources to dedicate to each of these projects. So again, looking at those optimal changes, where do we allocate those resources and where can we reduce that highest level of debt with the lowest level of impact. Here's another roadmap style view, if you like. This one is actually looking at the interdependencies now between specific technologies that we're using and maybe particular services or applications that we're delivering. The reason I'm showing this is it's a key concept to remember where you do at times have this idea of applications that are using all the technology, and that might be the case for a significant amount of time. And one way of doing that is to actually visually depict how, in this case, for example, a specific CRM system that we have is still using technology that the standard support has ended. Okay, and now this is, again, a classic case of, do we migrate to newer technologies? Do we sit with the costs for now? And actually, is it worth making those changes? And it comes back to some of the technical debt ratios we've discussed, but significantly it comes down to some of the key metrics that capture people's attention, which of course is the cost. What is the cost of fixing this now over the cost of living with this for the next 5 years? These types of views are some of the key ones to try and get those stakeholders' attention, to understand how these changes are affecting the things that they're working on as well. And this again can act as almost like an impact analysis style view. These are the areas that are going to be impacted by any potential changes that we make, because as you can see, it's worth noting, nothing within an architecture lives in isolation. You've got things connected to other things. As soon as you lift one thing, you will be affecting another area. So it is worth considering that end-to-end system and seeing how a particular area might affect changes in another area. Another key aspect is this concept of heat mapping. So some of you might have seen some of the road mapping webinars we've done previously. I mean, this is certainly one of the areas we've talked about in much more in-depth. And we can certainly send that on to anyone who's interested afterwards. But there are already some standard frameworks or approaches out there for how you can actually start tagging things within an architecture. So you might be familiar with some of the concepts in here, like tolerate, invest, migrate, eliminate. This is how we can actually start identifying from a technology perspective, what should we be keeping? Maybe what applications should we be refreshing or redesigning based on the improvements that have been made to the code? These are the first stages of a roadmap, really, where you're starting to tag things and you're trying to use the data that's available to drive some recommendations. Now, you'll see a few GIFs, if you like, running along the right-hand side. And another key aspect for these visualizations is that use of color. So it sounds relatively simplistic, if you like, but it is one of those things that does communicate that information clearly and effectively without actually having to dig away through an Excel spreadsheet. These are one of the ways that you might try and communicate some of the key aspects or some of the key metrics that you capture. The same goes when you start producing heat maps. So if you do have business capability maps or technical capability maps, once you start clearing up that tech debt, you need to make sure that you are providing a clear direction for that team. You want to make sure that, yes, there might be technologies that are outdated, but they're still being used. And of course, caveat that with the rationale or the waivers as we discussed earlier. What you don't want is that for that tech debt to start creeping back in because people are unaware of the changes that have been made or unaware that there are actually technologies now that are unapproved. So make sure you've got all those bases covered. And of course, don't mark anything for disposal unless you have a replacement for those things. This comes on, I guess, to one of the final views, and that's the different scenarios that you model. So we talk about a trade-off analysis in Abacus, and of course, any of the tools that you're going to be using to manage tech debt. One of the first things you'll want to do is understand, well, where are we now, as we showed in those roadmaps, but what options do we actually have to choose from? Now, from a technical debt perspective, there are some key areas that are worth considering, such as the risk associated with making those changes, maybe a reduced service to customers. Of course, there's going to be some other technical risks involved for the interoperability and integrations of the systems that are working alongside those ones you're making changes in. There's the remediation costs, of course, from a financial perspective. There's perhaps the efficiency of those systems as well. And another key metric in there is the reliability. Hopefully every change we're making is trying to move to a more positive outcome And yes, there are some trade-offs, as you can imagine, throughout those systems, but it's about choosing which option is best. So this is in terms of cost reduction or debt consolidation. These are the terms that we're going to be using for monitoring tech debt, for road mapping the changes that we're making, and understanding how these architecture views and these trade-off analysis techniques allow us to choose the best option. And it really is something that I guess is used these days, and it's quite interesting to think of all the recent changes. What kind of technical debt, if you think about it, has actually been accrued these days in the cars and the planes we use. They're all trying to integrate machine learning and AI into everything. There must be a huge amount of tech debt accruing in those areas. Even when you think about more complex systems, companies trying to manage all the IoT devices, there's chances that engineers are going to be making mistakes across those. And now that there are tighter deadlines, we're trying to ship code faster, trying to get those features out the door. There's the danger that we are making those short-term decisions to make sure that we are reaching time to market. And there is always that tech debt looming above us, if you like, in terms of, yes, we're making some shortcuts in the time being or for the forefront, but we do need to start paying that off over time. Bringing that back, I guess, to how this is actually going to be managed, it does fall very closely in line with some of the standards that are already out there. And the reason I say that is because this is all based on some fundamental concepts. We talk about enterprise architecture governance. There are principles you need to follow, guidelines and roadmaps. There are process checkpoints. You want to design and deploy things in the context of an EA implementation. And all of this is essentially underpinning through the frameworks, through the methodologies that we use, and hopefully this kind of guides us all to reducing an overall tech debt ratio throughout the organization itself. Now, it's quickly worth mentioning, I guess, just before we move to some thank yous, I guess, and some Q&A sessions, that we do have an Enterprise Architecture Digital Summit coming up over the next few weeks. And we'll be deep diving into some real-world examples that we've worked with customers on technical debt, but also on some key areas for application rationalization, how we actually start delivering value to stakeholders through different projects and use cases. And what you'll find is you'll find an opportunity to actually ask customers how they manage with these real-world situations. It's easy for me to sit here and tell you how to do that from a theory perspective, obviously trying to use some of the industry knowledge that we've gained over the past 20 years. But this is your opportunity to actually speak to these people and see how actually things are quite similar. There might be different organizations, of course, involved in different sectors and different domains, but everyone is starting to tackle the same problem. And hopefully we can all try and align on a single way of actually doing that as well. So finally from me, I guess, a quick thank you. You will actually see us at the Open Group event. You'll probably hear me speaking again at the Open Group event as well. So I look forward to catching up with anyone who's going to that. And I believe we do have time for a Q&A session. So if there are any questions, of course, there's a chat window. I'm sure Simon or Tim will be reading those out. If not, they've been answering those already. So feel free to ask your questions in there, and I'll be more than happy to go through those with you.
That's great, Andrew. Many thanks. Yes, we've had a very active exchange of views in chat, and we have plenty of questions in the QA facility. So, Tim, if you're happy, do you want me to just read through them top to bottom?
Well, I think I've already answered some of them. I think there is a few outstanding. Do you want me to read them out?
Absolutely, Tim. You'll understand them much better than I will, so you'll be able to interpret them. So please go ahead.
I'll still read them out exactly. So there definitely were some early on that I think I kind of covered. But I know that my take was the first one that's outstanding was one from Catherine King, where she asks, does the development cost in that equation, that was when we were talking about your debt ratio stuff, represent development of a new solution? So the equation is fixing existing solution versus replacing with new. So Andrew, do you want to start with that one? And you answer it too, but you...
Yeah, sure. So the actual technical debt ratio itself, we talk about remediation costs and development costs, and I guess those can fall into different categories. And we've talked about that in terms of monetary terms for new features, but really that technical debt ratio is about trying to fix existing systems. And we say technical debt ratio in terms of remediation costs and development cost. cost, monetary terms, or time-wise is something that is actually worth looking at, because both of those actually fall into a category of how you actually measure tech debt in general. The reason we say cost, I guess, in terms of monetary terms, as I mentioned, that does tend to catch most people's attention if you're going to be reducing the cost of something. But generally, we try to reduce that tech debt ratio, and obviously those smaller values means it's easier to work with. The other thing about the remediation costs, very quickly, I guess, is in theory that can be a function of any code quality metric as well. So it doesn't always have to be some kind of time or cost or monetary terms basis, but you can make that in terms of code complexity within that code base itself and measure that as a technical debt ratio too.
Oh, excellent, Andrew. Yep, nothing to add to that. So then Fernando had a couple of really great questions. So I'll read out his first one, and I'll take it first, Andrew, as well, and to you. But so Fernando asked, what might be a recommended approach to sell the need of tech debt payoff to business leaders who want to have the feature ready, inverted commas, for tomorrow, so they're impatient? Do you have any experience regarding the acceptance of that payoff need? So my quick take on that, first of all, is obviously one of those. This was asked before you put up your trade-off slide, Andrew. So that's the fundamental thing we need to sort of appreciate, is there's the kind of holy trinity of metrics that people all know, which in any decision there's a quality, time, cost trade-off. Any of your project manager friends will tell you that. So you can't have everything right. So there's going to be one lever that you have to pull, and what effect does that have on it? The other dimensions. So that's a three-dimensional trade-off analysis. Andrew obviously showed a five-dimensional one. Really, it comes down to what are the KPIs you're trying to optimize. Okay. So what's important when you talk to impatient or people who want everything tomorrow? You say, look, that's fine. We can shorten the time. I've no problem with that. But either you're going to have to give us lots of money to do that, or you're going to have to relax your quality criteria. What is it? Because we're not magicians. Okay, so that's the fundamental trade-off that you need to bring to people. And again, it comes back to EAs not being the no people, not being the police. So no, you can't do something. It's about saying, yep, that's no problem. We'll give you a waiver for that. We're perfectly happy to do that. Now, of course, you get into the kind of slightly negative thing, which you've got to be careful of, which I'll talk about later. But the whole, you've got to be careful it's not seen as an I told you so card. Because you basically said to someone, look, we're doing something that we think is probably not strategic, but I get it, it's tactical. And you're the boss, so we'll do it. But we're going to record that. So that's my kind of take on that. Andrew, do you have anything?
No, that's fine.
Good, sorry. So the next one, then Fernando's follow-up question was, and I'll leave this one to you, Andrew. So how do you approach the business when you find old technical debt, but you need to address it? Okay. So should we approach the business to have and kind of ask them to fix the technical debt that, as you said, it might even be invisible. So the classic known knowns and the known unknowns. So how would you suggest that when you discover something and you're the bearer of bad news, do you have some sort of tips on how you might try to approach that awkward conversation?
Yeah, I mean, I guess it depends who you're speaking to as well. So when we've talked about technical debt in terms of like a software concept, and it can get quite complex in terms of how we start measuring that. And trying to convince, I guess, people to make those changes is the reason we bring it back up to some kind of monetary value. Try and put a cost on tech debt, because that's one of the key ways you're going to be driving change. You tell anyone that you're going to be reducing the costs over the next 6, 12 months time, and I'm sure they'll be signing off that project. But the idea is to try and use that trade-off view again. You have to give people options of what they can choose from. You have to make sure that if you are finding things that does have tech debt, that just because you didn't realize it was there and you realize there's a lot of underlying problems, that it doesn't keep getting ignored. Tech debt, I guess, fundamentally probably comes from management or from processes that are actually happening internally, or probably, hopefully, the rare scenario is bad engineering. So it is about addressing each of those concerns for each of those stakeholders. And similar to those dashboards I showed, you do want to start tailoring those views, because not everyone is going to have the same view on tech debt. Not everyone's going to be able to be addressed in the same way. So you do need to start tailoring that message for your audience to make sure that you're kind of playing their cards and making sure that you're addressing their concerns rather than, I guess, your own at that time as well.
Fantastic. So I can see lots more questions coming in. So keep typing your questions in the Q&A. If we don't get to them today, I think we get sent these questions, and we'll reach out to you sort of directly afterwards with some sort of answer as well. Okay, so I'm up to Krishna's question here, which yeah, Andrew, yours was asked 15 minutes ago. So there's lots of questions. So do technologies like containerization, API-driven development, wrappers, etc., silently contribute to technical debt? Krishna certainly thinks so. I certainly think so. I presume you're going to agree, but yep.
Yes. Yeah, I was actually looking at a visualization yesterday around, we talk about things like being broken down from services to microservices and containerization of these technologies, and that idea of it then being able to easily be shifted from one area to the other. And it is quite a cyclic process in that things do tend to come back to stage one, where things again are quite difficult. There's breakdowns in code, there's the fact that you're containerizing everything and hopefully reducing the risk associated to that. But that does tend to then be, of course, tech debt, and you will have tech debt within those kind of containerized environments as well. And again, it isn't just from that code-based perspective. You can start thinking of this, as you mentioned, as a risk management process. You know, there are risks inherent in everything that you're doing, regardless of the way you're doing it. So it is just trying to decide what is the best option available to us at that point in time.
That's excellent. Okay, so we've got a question here from Sergey. Who should be responsible for technical debt calculations? And he gives, I think, an example of an organization, 2,000 plus now. I'm not sure what EMP is. Employees, probably. So, yeah, some sort of medium-sized, organization. Who would do these calculations?
Yeah, it's a good question, actually, because, I mean, technical debt, I guess, you might say stems from upper management, but maybe is executed by the engineers that are actually writing that code. So the engineers themselves, of course, have to take ownership, and they are writing code quickly to get features out the door. And despite, I guess, being pressurized and there might be limited options, but as the engineers, and I guess as an engineer myself, we have to take ownership of the things that we write. And if it gets to the stage where you do see bad practices or things aren't going quite correctly, you do, I guess, need to make that point of how things can be changed. And it's the same with, I guess, any real-world example. There's always going to be one good engineer. There's always going to be someone who stands up for what they think, I guess, is right. Yes, convincing people can be difficult, but it is just trying to make sure that people are aware of it at the beginning. So there is ownership from the engineers. There's ownership from management. Now, being on the front line of writing that code, you're obviously going to see those issues from a different perspective. So again, it is just about making sure that people are aware of that. So raising awareness of tech debt, but also you do have to kind of bear the burden and share that ownership throughout the organization. Both engineers and management have to share that, I think.
Yeah, no, I agree. And what I'd add to that is you talked about gamification. You talk about trying to be transparent. We're certainly firm believers in not sweeping any of this under the carpet. You have role-based access, so of course you don't have to necessarily name and shame to everybody, but those who have a need to know should feel perfectly whatever you want to call involved. And so there's the concept of transparency. Okay, now from a pragmatic point of view, to Sergey's question about who calculates it, so Abacus has algorithms, right? So we have a whole no-code algorithm ability. So of course we can ship it with algorithms that already do the calculation for you. So technically no one does it, the machine does. Abacus, the machine does. But we might give you the wrong answer. So it's always something that people need to take some ownership of, as Andrew said. And it's only going to ever be as good as the information that's put in. The classic garbage in, garbage out thing. But by having a concept of, like I say, a waiver or something like that, some vehicle or some entity by which you can start to reason about these debts, and then, of course, have them transparently available to everybody. People are using the dashboarding system to collaborate. Okay, you saw Andrew show the chat features. So people are starting to go, hey, are you sure about this? I think you might be a bit pessimistic. Oh, hang on, I'll change this number. Right, let's rerun the calc. Yeah, okay, cool. It's within boundaries now. So that kind of democratization is what everyone calls this. Democratizing EA and having everyone involved transparently. And that's okay. We're all in this together, right? You don't need to sweep any of this under the carpet. You certainly might use your role-based access to hide it from certain people. For example, there might be a project coming along that's going to remediate a whole lot of technical debt, which is going to shut down a whole lot of systems, and people are going to lose their jobs. Okay, so that kind of stuff you might want to be a bit protective of, but basically try to make this transparent and have everyone helping. Okay. So Pranav, he asked, I was wondering, is there a formal way to calculate or estimate amount of technical debt in an enterprise? So I guess the short answer is yes. We've just been talking about it now, in fact. I'm not sure, we obviously didn't give the formulas literally that are in there in the tool. We've got all these algorithms. Andrew, is there any, yes, there is ways, in fact, many ways. Just make a comment on that.
Yeah, of course. I think you would have seen through the slides how we've tried to classify that in slightly different ways. So when we start talking about things like the risks associated, the cost of fixing technical debt, the impact of that debt. So there are different metrics or KPIs that you can use to pull that up to different levels. And yes, as Tim mentioned, there are various algorithms you can use to try and help calculate that debt as well, in different terms, of course, because one of the key things is making sure that you are on the same page as everyone else. And if you do have data available, you can either accrue that to specific projects or programs, to specific systems. You can, of course, do that on architecture level, so an entire organization level. And so you can decide on who needs to see that information, but also decide at which bits you want to pull that up to and what levels you want to pull that up to. But absolutely, you can do it, if you like, an architecture-wide tech debt ratio or a tech debt score, if you like.
Great. So we've got a question here from Andrew, and actually Doreen's one straight after. It's similar, but we'll take Andrew's first. So how do you go about collecting the data that drives the algorithms calculations to determine the value of technical debt? I'll let you take that one first, Andrew, and I'll see.
Yeah, sure. So I guess there's the traditional ways, and I feel like the relatively older styles ways of working, which is you can kind of throw an Excel spreadsheet out to someone to fill in, and that has some of its advantages, but certainly has some very key downfalls or pitfalls. And the kind of way we've approached this, and quite successfully, is to make sure that that data is available for everyone to fill in where they feel comfortable filling that in. So you would have seen some of the dashboards I showed earlier on. It's about trying to embed this in systems that people are already using. So whether you are just sending out surveys or queries, or embedding this in SharePoint or Microsoft Teams, you're trying to make that data available. And dare I say, maybe not even in an enterprise architecture environment. Make that available in somewhere that people are used to working collaboratively. Make sure that data is collected. Then the architects can, of course, start using that data to start running some of those situational differences or situational analysis metrics that you can start calculating then.
Yep. So the only thing I'd add to that is it's not all manual. So I did already reply to, I think, a question somewhere along the way about, where does the data come from, especially if you started to talk about dates and things like that. So you can use integrations with things like Technopedia. There is a wealth of off-the-shelf kind of data out there. TOGAF has the technical reference model, right? So when you talk about standards, and if you're going to go and say, look, a certain standard is approved or is satisfactory for an organization to use, these are reference models and these are benchmarks that are out there already that you can leverage. Okay. So I wouldn't, you don't ever need to, we're not going to give you a spreadsheet necessarily with, 1,000 rows and 10 columns to fill in and it's blank. Okay, a lot of the stuff can be pre-populated from these sort of things like Technopedia and stuff like that. But yeah, fundamentally, some of the things are going to be human, and there's no doubt about it, that they need to be manually maintained, but that's it. It becomes a job description, and as Andrew said, if you're embedding it in something like Teams, people just see it as a portfolio they need to manage just like any list that they would manage. And obviously they then are providing input to the architects to maybe run a calculation that they don't even necessarily know that calculation is being run. As they choose a technology, there might be some incurred or some kind of implication that happens then that happens behind the scenes and is calculated behind the scenes. Okay, so we've got 1 minute to go. So I don't think we'll get through it. So Doreen asked a sort of similar question to, a suggested set of properties. So I guess, Doreen, talk to your account manager. We've got templates and things like that we can work with. So we'll take that offline and we'll talk to your account manager about getting some of these things. It's essentially have a look at the waiver construct in one of our standard libraries, the Abacus framework, and you'll sort of see some of the metrics that you need to be tracking in there. I don't know if I've got time for Mark's question, Simon, given that we're at the top of the hour. So we'll take that one offline, Mark, and we'll get back to you with that. There's Fernando's asked some more as well. So sorry, we have run out of time, I'm afraid. But thank you, everybody. And yeah, back to you, Simon.
Yeah, thank you, Tim. Thank you, Andrew. Great presentation. Really enjoyed that. I'd like to thank everyone for their time for joining us today. I'd like to thank Tim and Andrew for their time, and hope we'll see you again in the near future, another Open Group webinar. So thank you, everyone. And goodbye.
Thanks, everyone.
Thanks, everyone.